Testing your software is really important, at least if you want happy customers. There's a lot of different ways to test software. In particular, it's quite common to start with writing unit tests. Unit tests are great, but writing them is a lot of work. And the bigger your codebase becomes, the more time you have to spend writing and maintaining your test. It's not uncommon that the testing code has way more lines than the actual application code. And if you're not careful, developing and releasing new features is going to become really hard, to a point where you feel like even a minor change is going to involve a lot of development work. There might be a way out of this by looking at other ways to test software. One in particular that I find really interesting is property-based testing. I'm going to show you how to do this in Python using the honestly awesome Hypothesis package. Before we dive in, I have something for you. It's a free guide that helps you design new software from scratch. You can get this at ArjanCodes.com/design guide. It contains the 7 steps I take whenever I design a new piece of software. If you enter your email address on the site, you get the free PDF in your inbox right away. So ArjanCodes.com/design guide. The link is also in the description of this video. A unit test generally defines a fixture, a predefined specific set of input values, executes code using that fixture, and then asserts that the result is as expected. This is also called arrange, act, assert in test-driven development. You can also follow given, when, then, which comes from behavior-driven development. The main difference is that arrange, act, assert describes what the test code is doing, whereas given, when, then describes it more in the way of what a user might do. There's a bit more nuance to it, but I won't go into that today. As opposed to unit tests, a property test checks that a function, program, or any system abides by a property. Most of the time, property tests don't need to know that much about the specific inputs or outputs of a system, they just check specific characteristics. Although property-based tests also rely on example data like unit tests, they're different because they test a property of the system by automatically generating example input data instead of using fixed data. Property-based testing is quite well known in functional programming. It was introduced by the Quick Check framework in Haskell. You can use this testing approach on all levels of example-based testing, from unit tests to end-to-end tests. There are all kinds of different properties you can test. For example, if you have a reversible operation like encoding and then decoding a string, you can test that the operation and then the reversed operation result in the same value. You can also test properties of data that the code that you're testing is manipulating. For example, you can test that the sorting function you wrote doesn't change the length of the list that you sort. In this case, you're testing the list length property. Another property you could test is that the result of a function call adheres to some condition. For example, if you're testing a function that generates UUIDs, you can check that the generated ID follows the UUID structure. I'm going to show you 2 different examples now where property-based testing helps write better tests. So here I have 2 functions, 2 ASCII codes and from ASCII codes. The only thing that these functions do is convert to and from a list of ASCII codes. So the first one, for example, takes a string as an input, returns a list of integers, which uses the ORT function to convert a character into its ASCII code. From ASCII code does exactly the opposite. So it gets a list of ASCII codes and then uses reduce and the character function to turn the list into a string again and return that as a result. This is a perfect example of where property-based testing can be helpful, because generally we don't really care about the specific strings that are being used to test these functions. We just want to test them with a bunch of different strings adhering to a bunch of different conditions. So I have another file here, test ASCII, where I've simply imported these 2 functions. I've not done anything with them yet, and now I'm going to add a few property-based tests to them. The first thing you can test is that if you take a string and you then encode it and decode it again, that you get exactly the same string. That's a nice property to test. So in order to get started, I'm going to import a few things from Hypothesis. So we're going to need given, which is a function that defines how the example data is going to be generated. And I'm also going to import a simple strategy. So that's from hypothesis.strategies. And we're going to need to generate text. So that's the text strategy. And now setting up our test is actually really simple. So given some text, and then we're going to have our function that's test decode inverts encode. And this is going to provide us text, so we add a variable test string, which is a string, and there's no return result. And then we're going to assert that from ASCII codes on to ASCII codes of the test string equals the test string, right? And you can also test the other way around. And now if I run this, let's run PyTest. So you see that it passed this test. Now this is going to generate a bunch of random text inputs. You actually have some control over that. For example, what you can do is provide specific examples. So I can add the example decorator here, and then I can say that I want the empty string to be part of the set of generated examples. And now when I run this code, it's going to include this particular example, though we can't see it at the moment. You can also add settings to, for example, indicate how many of these examples you want to generate as a maximum. For that, we're going to need the settings decorator. So that's settings. And then you can provide a max examples of, for example, we want at most 100 examples just to make sure that our tests are not going to run infinitely. For the simple function, that's not really an issue, but that's sometimes helpful. Another property that we could test is that the length of the encoded list is the same as the length of the input string. So in this case, we're also given text, and we're going to test the list length, same as input string. And then the first step is to create an encoded list. So that's 2 ASCII codes of the test string. There we go. And then we're going to assert that the length of the encoded list is the same as the length of the test string. There we go. Now we can run the tests again. And we see that now 2 of the tests have passed. So that's how you build up your property-based test. And as you can see, it's quite different from running regular unit tests because we're not actually defining exactly what the input data is going to be. We simply let hypothesis generate the data for us, and we're testing properties. ASCII encoding and decoding is a pretty simple example. What I want to show you now is something that's a bit more complex. But before I do that, give this video a like if you're enjoying this so far. It's going to make me really happy. Like a cute, happy little puppy. Okay, sorry. I'm like a big child. Anyway, here I have an office example. There's an employee enumerated type that has different types of employees, CEO, manager, engineer, everything. We have a function to generate a random team that gets a size and that returns a list of employees. So how that works is that, well, it should generate a random team with exactly one CEO. So we have here the team members without the CEO by removing it from the list. And then I'm generating here with a simple for loop a list that contains one CEO. And then I return the team. I also have a function to fire a random employee. So this creates a copy of the team without the CEO. And then if the length of that team is larger than 0, it removes a random employee from the team, and otherwise it removes the CEO from the team. So this fires the CEO last, which is pretty close to real life, right? Now, how do we test this? I have a file called test office, and here I have a simple example of testing the generate random team function. So given integers, very similar to what we did with the ASCII encoding and decoding, but here I'm using integers and not text. So this is another strategy. I'm testing that the team size is the same as the size that we passed as an argument to generate random team. Now, let's see what happens when we run the test here. Here we see that we now get a failed test, because if the team size is 0, we see a falsifying example here, we have a problem. So what's happening exactly? Well, if we pass a size of 0, then actually the CEO is still appended. So we don't get a team with a size of 0. And this is really good because now we know, oh, hey, we didn't really consider this case carefully. So we have to think about how we're going to deal with that. And in general, how we're going to deal with the situation where we get a negative team size, because then we didn't clearly define the behavior of this function. So what we could do is fix this by raising a value error if the size is 0 or less. There we go. So now we've covered this case. Now the test still fails because when we call this with a negative team size, this is still going to raise a value error, which will fail the test. So what we need to do is to write a separate test to cover the value error case. So let's import PyTest. And then we're going to add a test for this. So I want to make sure that this is going to raise a value error, and then we're going to write generate a random team, and we're going to pass it a size of 0. And now this test, of course, still fails. So what we need to do is to make sure that team size here is always positive. And we can change that by changing the strategy. So in this case, we can provide a min value of, let's say, 1, and let's also supply a max value of, say, 20 to limit the number of test cases that Hypothesis is going to generate for us. So let's run PyTest again, now that we've made these changes. And now we see that the tests pass. We have 2 tests instead of 1. Now here, for testing a negative team size, we could actually also use Hypothesis. So what we can do instead is given integers, and we just want a max value of 0. And then we're going to get here a team size, just like in the other test. And we're going to pass the team size to generate a random team. Let's run PyTest again. And now you see this still passes, and we're now relying on Hypothesis to generate a bunch of different test cases for us. Another thing we could do is test that a team has a CEO. So let's write another test with given integers. And also here we need to make sure that we have a minimum value of 1, because we want to make sure that we're dealing with actual teams. And let's again use a max value of 20. And then we're going to test that a team has a CEO. And this also gets a team size, which is an int. Let's first create a team. And then we're going to assert that employee.ceo is in team, like so. Now let's run the test again. And we have now 3 pass tests. So this is how we build up our test cases here. So as you can see, Hypothesis is pretty flexible in how it generates data. Let me show you another example. So we have the fire random employee function as well. So let's write a test. And again, we want to have a min value of 1 and a max value of 20. What we're going to test is if we pass a team to fire employee, that we're going to get a list back with a length that is 1 less than the original team. So we generate a team. And let's create a copy so we can compare the length. And now we're going to fire a random employee from the team copy. And then we're going to assert that the length of the team copy equals the length of the team minus 1. And let's run the tests again. There we go. And now we have 4 pass tests. Now, if you look again at these tests, you see that we have to write a bit of boilerplate code to generate teams every time. And that's because we have the integers strategy, but actually what we would like to have is a strategy, a custom strategy that generates teams for us. So it's actually possible in Hypothesis to write your own custom strategies that build on the basic strategies that Hypothesis already offers. And for that, we're going to need the composite decorator. And with composite, you can create your own strategies that you can then use after that in your test. So we're going to use the composite decorator. And let's say we have a teams strategy. So not integers, but teams. And a strategy in Hypothesis always gets a draw function that allows us to draw values from another strategy. So that's the draw function. And what's the type? It's a callable. There we go. And what we also going to need is, if we want to be precise with the type definition, is the search strategy. So we're going to rely on integers. So what we will put into it is a search strategy of integers, and then this is obviously going to return an integer. And then we can also define extra arguments to our composite strategy. Like for example, we'd like to have a min value similar to the integers. Let's say default that's 1, and a max value, which is also an integer, and let's say that's default 20. So this is our teams composite function, and then inside this we're going to draw a random value using this draw function that we have as an argument. So that gets integers, and we pass it the min value and the max value that we get as an argument to our composite strategy. There we go. And now we have our random value, we can generate the team. So, and for that we call our generate random team function. And of course, if you need more complex data generation, you can write your own custom functions for generate a variety of data and directly integrate them into the hypothesis framework in this way. So now we have our composite strategy. So what we can do now, for example, is in this case, testing that the team has a CEO, we don't use the integer strategy, but we use the teams strategy. And then this is not going to get a team size, but this is going to get a team, which is a list of employees. And now this line is not needed anymore. And the same thing for fire employees. So here we're going to get the teams strategy result. So that's again a team, which is a list of employees, and we don't need this particular line. And now if we run the test again, we should get exactly the same results. Yeah, there you go. So building out your own strategies is really useful because it gives you a lot of control over the data that you generate. And these strategies, they're really, really flexible. Let me show you a few examples of what you can do. I have a simple file here, so I'm not even going to use the strategies directly as part of a test, but I'll just show you what you can do with them. So for example, if I want to print some integers, I can do print integers, which is my strategy, and then I'm going to draw an example. So what this does now is it's going to print a single integer. We get a warning that we are not supposed to use this outside of the test environment, but it's just to show you what's possible. So this is the random integer that it generated. We can do more. For example, I can provide the min and max value as we saw before. So if I provide a min value of 1 and a max value of, let's say 10, like so, and I run this code again, you see that it now generates a number between these ranges. Another thing you can do, which is really fun, is that you can also apply filters. So we have this min value of 1, max value of 10, but now what I want to do is apply a filter, which is a, let's say, a lambda function that takes an x, and the check is that the x divided by 2, or x modulo 2, sorry, should be 0. So that basically means we only want even numbers. And now we draw an example from that. And now you see that we get an even number. Well, the last one was also accidentally even, but now we get an even number. If I change this to be equal to 1 and I run this again, and now we get an odd number as an example drawn from the integers strategy. And you can use these kind of structures in your given decorator as well, obviously, because that's what it's intended for. So a lot of control over how you generate the example data using hypothesis. A final thing that I want to show you is that hypothesis can actually generate test code for you by simply running the hypothesis write command that you see here. So I'm passing the generate random team function to the write command, and then I'm going to output this to test office 1. And when I run this, it now has generated a test file for me. Let's see what that looks like. So as you can see, it has now generated a simple test for us that generates a size and calls generate random team, which is really neat. So we can do the same thing for fire random employee. So now it has generated a test file for that. So let's see what that looks like. And now you see it has actually done something really neat, which is creating a team, which is sampled from office.employee. So to recognize that something needs a list of employees, and then it calls fire random employee on that particular team. So I think this is really cool that this actually works, and this might save you quite a bit of time because now you don't have to write these tests anymore yourself, but you can get started quickly with hypothesis, let it create a few tests for you, and then you can expand on that code yourself. Overall, I think hypothesis is a really useful addition to your testing toolkit. It has a ton of possibilities, and I've only touched the surface in this video. I have a few final thoughts. A really powerful aspect of hypothesis is the flexible data generation options. For example, there are strategies for generating NumPy data structures or pandas data frames. There are specific testing features for Django applications. You can even imagine that the data generation system can be helpful for other things than testing. For example, if your application needs to generate random selections of things with specific conditions. Hypothesis also offers something called stateful testing or model-based testing, where it doesn't just generate data, but it also generates tests. In this case, you specify a number of primitive actions that can be combined using a flowchart. And then Hypothesis will try to find sequences of those actions that result in a failure. It's definitely something I want to delve into more. Let me know in the comments if you have any experience with this that you'd like to share, or if you'd like me to do a separate video about that topic. Using a tool like Hypothesis is a good way to think more out of the box about how you test your code. This doesn't mean you shouldn't write normal unit tests anymore. Depending on what you need to test, a regular basic unit test can be just the right ticket. Remember that software design principles such as keep things simple also apply when you write test code. If you want to get started writing unit tests for your code and do it in such a way that you improve the design of your code as well, watch this video series where I show you exactly how to do this. Thanks for watching. Take care. See you next week.